Physics is an important field in our life. We see, hear, and feel things related to physics anytime, anywhere. In short, physics is always around us. Assalamualaikum and salam sejahtera to all teachers, students and all viewers. Welcome again to my channel, Cikgu Hasnita. This is Physics KSSM Form 4 for DLP classes Theme 1 Elementary Physics, Lesson number 3 on 1.2 Scientific Investigation. So for today, we are going to discuss on interpreting of graph, and also we'll do some worksheet on activity 1.2 from textbook. Okay, so before we begin with our lesson, scientific investigation, let us first do the tracking on exercise on formative practice 1.1. So you may refer this discussion in your textbook, page 9. So there are 3 questions you are given there. The first question you can see in figure 1.6, it shows Encik Effendi taking a measurement of Whaley. And there is a reading written there 1.65 meters. So you have to state first what is the measured physical quantity. So what is Encik Effendi measured? And then in question B, you have to state what is the measured base unit, the symbol of the unit, the magnitude of the physical quantity, and also the symbol of the physical quantity in the situation. Okay, so what is the first answer? So what is Encik Effendi measured? Very good. So Encik Effendi is measuring Whaley's height. So the answer is height. Okay, then how about B? What is the measure base unit? Height is a type of length. It's an example of length. And we measure length in a unit of meter. And the symbol for meter is m. And the magnitude of physical quantity, this is referred to Whaley's height, which is 1.65. And the symbol for the physical quantity, so this height, it can be represented with the symbol of H, or also you can use L. No problem. Okay, now let's check for question number 2. Okay, question number 2, first question, they ask you to write what is the difference between scalar quantity and vector quantity. So remember our second lesson on base quantity and derived quantity and also scalar and vector quantity. So second, you are given a passage. When Aisha wants to travel to Kota Kinabalu, the distance from her house to Kota Kinabalu is 333 kilometers. And she drives her car at a speed of 80 kilometers per hour along a highway. She wants to reach Kota Kinabalu in 3 hours. And therefore, she increases the speed of a car with an acceleration of 1.2 meter per second squared. So what is the difference between scalar and vector quantity? Very good. So scalar quantity is a physical quantity that have magnitude only, while vector is a physical quantity that have both magnitude and direction. Okay. Now let's check for the passage which one is the scalar quantity and which one are the vector quantity. Okay, so alright. So the scalar quantity, first we have distance 333 kilometer, and we also have speed 80 kilometer per hour and the time 3 hours. While for the vector quantity, we have acceleration given 1.2 meter per second square and also displacement. Okay, where is this displacement coming from? It is actually from the distance of 333 kilometer per hour. When only the magnitude is stated, so it is distance scalar. But once the direction is stated from her house to Kota Kinabalu, so now the distance becomes a displacement, a vector with magnitude of 333 kilometer and a direction of from her house to Kota Kinabalu. Okay, so I hope you are clear with question number 2. So now let's proceed with question number 3. Okay, question number 3, we have Rina and her friends took part in a treasure hunt held in conjunction with a science fair in their school. And each group had to find several objects which is hidden in the school compound within 30 minutes. Okay, And the objects hidden are as listed in figure 1.7. So first we have container filled with 500 milliliter of pond water. Second, we have a unique piece of rope with a mass of 950 gram and a rope of length 1.5 meter, camping canvas of area 7.2 square meter. So which one is a base and which one is or are the derived quantities? Okay, so I think you can do this easily. Base quantity, first we have time. Don't forget the time is mentioned at the information given above, 30 meter. And then we have mass. Okay, mass of the water cone, mass of the unique piece of rock, 950 gram. And then the length of the rope, 1.5 meter. While the derived quantity, we have volume of the water pond, which is 500 milliliter, and area of 7.2 square meter. So by this, we are finished doing formative practice 1.1. Okay, and you may do correction if there is any. So we have finished with the formative practice 1.1, and now let's begin our lesson with scientific investigation. So under this content standard, there are 3 learning standards you have to fulfill. So for today's lesson, we are going to discuss the first learning standard, where I hope that at the end of this video, you will be able to interpret a graph to determine the relationship between 2 physical quantities. And to begin with, let's take a look at this picture. What are those 2 young scientists do? Yeah, they are experimenting. The girl might ask, what will happen if I add this orange liquid into the blue one? And the boy said, I don't know. Let's find out. So they are investigating. Yes, the word is investigating. So they are trying to find out what might happen if they add the 2 different solutions together. So this is what we call as a scientific investigation. For example, what will happen to the extension of spring if I hang more load into it? Second example, what might happen to the acceleration of trolley downward an inclined plane when I increase the height of inclination? So scientific investigation normally begin with a big why, questions. And then from there, we come up with a hypothesis, an early prediction on the relationship between the 2 variables, namely as manipulated and responding variable. And then we will design the experiment. We come up with a suitable apparatus and material to run the test. And from there, we will do data collection. We present our data in a table, and from there we will do analysis of data and interpretation. But what are we going to do today? We will be focused to the 5 to the 5th step, okay, which is analysis and interpretation. Okay, so this is the 5th step in scientific investigation, interpreting graph to determine the relationship between 2 physical quantity. So in physics, how do we interpret our data? We do interpretation of data by plotting a graph. Okay, so this is a question for you to think. What is the purpose for plotting a graph in a scientific investigation? Definitely, it is to determine the relationship between the 2 physical quantity. As I stated before, the manipulated variable MV and the responding variable RV. When you are plotting your graph, you might get a different shape of graph depend on what experiment you are doing. And how do we interpret this graph of different shapes? So I will show you 6 examples of graph which you might get when you are conducting an experiment. Okay, so now let's take a look at the first type. So when you are given this type of graph, to interpret the type of the graph and to determine what is the relationship between y and x, the 2 variables, so there are 3 things you have to look carefully. Number 1, the shape of the graph, the line. Either it is a straight line or a curve. Second, the gradient. Either the gradient is positive or negative. And number 3, you have to look where the graph started at. Either it started from the origin or not, or does it pass through the y-intercept. Okay, so now let's take a look at this, the first graph. So what can you say about this type of graph? It is a straight line graph with a positive gradient. How to determine either the gradient is positive, negative? If the line is going up, so we say the gradient is positive. And if it's going down, so the gradient will be negative. So this is a straight line graph with positive gradient, and yes, it passed through the origin. The type of graph, it is a straight line graph with positive gradient that passes through the origin. So from here, what can we say about the relationship between y and x? We say y is directly proportional to x. Okay, so what else can we get? What else can we determine from this graph? You can find the gradient. How to find the gradient? You can mark any 2 points along the line and calculate the gradient by delta y divided by delta x. And last but not least, we can come up with a linear equation where here y equal to mx plus c. Where is the c? C is the y-intercept, and since this graph is started from the origin, so the value for c is 0. So enough for us to just write y equal mx. Okay, so now let's check with the second type. Okay, you are given with this type of graph. It's a bit similar with the first one, but let's see where is the difference. So first again, check the line, either it is a straight line or a curve. Then check for the gradient. It's going up, right? So the gradient must be positive. And then you have to look. For this graph, it does not started from the origin, but it passed through the y-intercept. So for the type, we say that it is a straight line graph with positive gradient that does not passes through the origin. Okay, and how do we say the relationship between y and x? We say that y increases linearly with x. Remember, if the line does not started from the origin, we cannot say it is directly proportional, but we say y increases linearly with x. And for the gradient, as before, we calculate the gradient by delta y divide delta x. Okay, mean y2 minus y1 divide x2 minus x1. The 2 points we are marking on the line. Okay, and then the y-intercept, there is a y-intercept here where the value is c. So the linear equation is written like this: y equal mx plus c. Okay, number 3. Okay, these are the third graph you are given. Again, you can see it is, yes, a straight line graph, but now it's going down. So we know that the gradient is, yes, negative. Very good. Then, does it pass through the origin? No, it doesn't, but it has intercept at the y-axis. So how do we say for this type of graph? Very good. It is a straight line graph with negative gradient that does not pass through the origin. So what can you say about the relationship between y and x? Can you guess? It's a good try. Yes. So we can say y decreases linearly with x. Okay, then the gradient, how to count? As before, it is delta y divide delta x. Okay, y2 minus y1 divide x2 minus x1. And we can come up with the equation. There is the value for the y-intercept, which is c. So the linear equation is y equal to mx plus c, where the value for m here is negative. So it can be y equal negative mx plus c. Okay, now let's check for number 4. These are the type of graph you are given with. Again, look at the type of graph. Is it a straight line or a curve? You can see obviously this is a curved line. Then how about the gradient? Both are going up, right? So we say the gradient is positive, yes. Then does it pass through the origin? Of course, it passed through the origin. So what can you say about the type of this graph? Very good. It is a curve with a positive gradient that passes through the origin. Then what can we say about the relationship between y and x? Can we say y increases linearly to x? Cannot, because the word linear means it must be a straight line. So for this, we can say y is increases with x. Y increases with x. Okay? Okay, then we jump to number 5. Okay, for number 5, okay, now you can see this is also a curve, but it's going down, it's sliding down, so the gradient will be negative. And does it pass through the origin now? No, it doesn't, but it has a y-intercept. Okay, it passed through at the y-axis. So what can we say about the type of this graph? It is a curve with a negative gradient that does not pass through the origin. Okay, now let's try the last one, number 6. Now before that, let us take a look at the relationship between y and x here. So we can say y decreases with x. Aha, now number 6. Okay. Okay, you are given a graph on the left side. It shows a curve. It's going down. Okay, so you know the gradient is negative, and it does not started from the origin or either the y-intercept. But look at the right side. It is a straight line graph, okay, with a positive gradient passes through the origin. If you look at the axis for both, and the x-axis, on the left it is x, but on the right it is the reciprocal of x. So how can we say about this type of graph? So this is a curve. We refer to the left side. It is a curve with a negative gradient that does not cut both axes. So what can we say about y and x? So we say y is inversely proportional to x. Inversely proportional means the opposite. Okay, the opposite relation. If x increases, so y decreases, and the other way around. Okay. While on the right side, what can we say about the type of graph? It is a straight line y against a reciprocal of x with a positive gradient that passes through the origin. Okay, so what can we say about the relationship between y and reciprocal of x? So it is y directly proportional to the reciprocal of x. Okay, so by when you show this type of graph number 6, so we know that either on the left or on the right, so we know that y is inversely proportional to x. So it seems like we have come to the end of our lesson. Time flies so fast. So as a conclusion and to test your understanding, either you can follow this lesson or not, let's do activity 2. This is activity 1.2 in your textbook on page 11 when you scanning on the QR code at that page. But if you don't have any scanner, I have simplified the work for you, where you just have to click on the link of this worksheet which I prepare in the video description. So you just go there and get your copy. Okay, so now let's check what do we have here. You are given a shape of graph where you have to describe the shape and to interpret what is the relationship between the physical quantity on both y and x axis. So are you ready to go? Let's begin with the first one. Okay, so what kind of graph we have here? You can see it is a straight line. So we just take on the straight line. Easy, right? And does it pass through the origin? You can see, yes, it passed through the origin. So you tick yes. Then how about the gradient? Positive or negative? It's going up, right? So, very good. Must be positive. Then how can you say the relationship between the current and the voltage? Exactly. So, the current is directly proportional to the voltage. Simple, isn't it? Okay, now let's check with the second. Okay, so what type of graph is this? The shape is, it's a curve. How about the second one? Pass through the origin, yes or no? Yes, of course. And the gradient? Going up, so it is positive. So how to say how the current relate to the voltage? Here we can say, remember? Okay, so we can write current increases with voltage. Okay, number 3. Now it is a straight line, sliding down, going down. So we tick on the straight line and pass through the origin. No, it doesn't. Gradient? Yes, the gradient is negative. So what can we say about the voltage and current? Yeah, very good. So the voltage decreases linearly with current. Okay, how about this one? Okay, now we have resistance against cross-sectional area of wire on top. So it is a curve. Yes. Pass through the origin. No. Gradient. Negative. Then, how does the resistance relate to the cross-section area of the wire? Yes. So we can say resistance is inversely proportional to the cross-section area of the wire. Then how about the bottom? It is, yes, a straight line graph. Pass through the origin, of course, and the gradient is positive. So how does the resistance relate to the reciprocal of the cross-section area of the wire? So we can say resistance is directly proportional to the reciprocal of the cross-sectional area of the wire. And actually both type of graph shows that the resistance is inversely proportional to cross-sectional area of wire. So I guess that's all the time we have for today. I hope you had enjoyed this lesson, and don't forget to be with me again in our fourth lesson, where I'm going to continue on analyzing graph. So today we have looked how to interpret a graph in order to determine the relationship between y and x. Till then, thank you very much for watching, and don't forget to give a thumbs up for this video if you like it, and also subscribe into my channel for the latest physics video. Again, thank you. Assalamualaikum and see you soon. Belajar demi ilmu, fizik di hatiku.